it's causing multiple cases to be executed. So here, although we have the C, so even though we have much, so here we have already, so we satisfied already that C is equal to green, but it did uh, continue until this hit this case blue, then break here. So omitting break so leads to unattended behavior. So where the switch continues will just execute until the, like here, and for our case here, until it did hit the break. So which is often a source of bugs. So it's like, what if you have a lot of case statements? So it's not a good practice that uh, you will. So it's up to programmers just to be make sure that you're cautious in using about the syntax of the programming language that you are using, making aware, because in, like, it's not throwing error, it's just allowing it. So in C++, so which is not a good one, it's somehow like an unsafe. It's so that's it, the our number 8 exploration. So it did, C++ allow us the it does allow, even though there's no, we forgot the break on the first and the two case in this example. So we're down to second to the last exploration in enumerations in C++. So in this example, we're going to show the implicit conversion to integers. So enums in C++ can be implicitly converted to integers. So even when it's not intended. So it's not. So this can lead to situations where enum loses its meaning and it's treated as a raw number. So for example, we have the enum of color, red, green, blue, and then so going to that color. So we're going to implicit, this is that one. Implicit conversion of enum to integer. So let's see what will happen. So when we see what will happen here, we run it again, hit the run. So okay, so it did pass so color as 1. So as you can see here, value of C, E, B. So what happened here is we set colors C is equal to green, so the value of C here, the value of green is 101, so it's giving us the integer 1. So when we pass C, which is here, we have the enumeration, which is color, to the print color function here, it gets implicitly converted to an integer. That's what I say from the start of the exploration. Enumeration are treated under the hood, it's treated as an integer. So 0, 1, 2 in this case, 0 for red, 1 and 2 for green and blue. So the enum is now treated as an integer, so which means its type safety is compromised. So yeah, who, like, giving you 1 instead of the, because we have here the colors. So which is, yeah. So okay, so that's the implicit conversion to integers, or second to the last exploration. Down to the last exploration in enumerations, in C++, enumerations in C++. So the last one is this one, we have like the assigning of uh, integer values to enumerations without casting. So a while ago, we'll just for the sake of, so that you will see it, I'll just delete this one. So we use the static cast like once or twice, or this time let's see if this program C++ will allow us to to will let us get past this program. So we're having this problem, so but by using the static cast, here I'll explain to you later. Then we're going to run, and hola, we have it's letting us pass through it. So here the cast is so it did, the value is, it did print as 5, but it's not a valid color, since it's not a color, 5 is not a color. So the enum is supposed to only hold red, green, or blue, but C++ doesn't enforce this strictly, so allowing other integer values to be assigned. So clearly 5 is not a color. So the integer 5 is not a valid color, but again, C++ allows assigning it to the enum. So, and then even though 5 isn't part of the color, so for example, if we have maybe, I don't know, green, which is number 4, or yellow, or let's see, white is number 4, 5 is pink. So yeah, it made sense because under the hood it's what you call this one, it's integer, right? But it's not even there, so it's out of range. So even though 5 isn't part of the color, but color enum, the assignment works, and the enum holds an invalid value, which is 5, because we don't have it here. It's supposed to be just colors. So this can lead the bugs when you rely on the enums for type safety, or when performing logic checks based on the enum values. So yeah, so this is the last exploration, the last example of exploration in enumeration types in C++. So in to summarize, so C++ with all those let's say with the 10 different cases of enumerations with different operations, and the conditions that the conditions that of the like different problems using operations conditions. So C++ allows many operations on enumerations that seems to be what do you call this one, illogical or unsafe, such as comparing enums to integers, what else, incrementing beyond the valid values, and performing bitwise operations. So while these are legal due to the underlying integer representation, as I mentioned, under the hood it's just integers of enums, so they can lead to confusing, or can lead to buggy behavior. So if it's not handled carefully, so it's more important for programmers to be mindful of this. Somehow it's flexibility. This to maintain the integrity and intent of using the enumerations for type safety and clarity of clarity in your code. So that's it for this laboratory exercise 5, C enumeration exploration of enumerations in C++. Thank you so much.